Most people don't know about the biggest weakness of AI, and in the worst situations, as I'm going to illustrate, this can lead to life or death decisions. So we are definitely in the era of AI, and people, in particular in business, wants to use AI for everything. Predictive AI, or in particular what we call machine learning and deep learning, these models allow us to predict. And let me give you a very simple example. If I look outside now and I see people wearing raincoats and having umbrellas, I can predict that it's cold and raining. That's a very simple predictive algorithm. I observe the world and I predict the value of something, here temperature for example, or the weather generally speaking. So this is what we call prediction, and that's what you do with machine learning, for example. You observe the world and you predict the value of something. I like this first very simple example of the weather because it illustrates something important. The thing I use for the prediction, the clothes, are not the cause of the weather, they are the consequence, right? So in many situations, when you do predictive AI, when you use machine learning, you don't need to understand cause and effects. And for example, top tech companies use extensively predictive AI to predict the next product you might like, from a TV show for Netflix or a pair of jeans on Zalando, for example. All these algorithms try to predict what you might like, but they don't need to understand why you like this pair of jeans or this TV show. They just want to do the right prediction. So predictive inference can be incredibly powerful, and these algorithms do not need to understand the why, cause and effects. And indeed, machine learning predictive inference relies on correlations. They are not made to answer causal questions and to understand cause and effects. And that's where it's getting interesting. Because a very good predictor, like the clothes people are wearing to predict the weather, are not necessarily causes, and you should definitely not interpret them like this. So let me illustrate with a final example. In the medical sector, sepsis, which is when an infection goes wide and leads sometimes quickly to death, is a huge problem for intensive care unit patients. And research have been done in this realm with machine learning to predict the risk of sepsis. This algorithm could help to flag a risk, and then a nurse will come and give antibiotics, which could save a life. But now imagine you don't understand the concept I just shared, and you look at the strong predictor of sepsis. It might be a sudden rise in temperature. And if you interpret this as a cause, probably you might want to lower the temperature of the person, maybe by doing cold therapy or giving a cold shower to the person. Well, of course, if you do this, you might kill the person really quickly. So indeed, this subtle difference has actually very deep consequences. Machine learning, predictive inference can be incredibly useful, but its main weakness is that it does not understand cause and effects. It's just measuring and identifying patterns and correlations. And as we all know, correlation does not imply causation.